Hey everyone, today we're going to look at methods for generating programmatic clicks, classic defense tactics, and potential ways to bypass those defenses. I'd recommend this video for anyone involved with clickers, writing bots for scraping and automation, and really any JavaScript enthusiast. As our test subject, we'll have a page with a counter and a button. When you press the button, the counter increases. Here's what that looks like in VS Code. Nothing fancy, just a button and a label, and a script connected to the page, which looks incredibly simple. We're storing the score in a basic score variable, attaching a click event listener to the button, incrementing the score by 1, and updating the label. It's all extremely straightforward. The only thing that might raise a question here is how I'm referencing the button, just straight up, without any ceremony. The thing is, I've declared it with an ID of button, and a property of IDs, in case you didn't know, is that a field with the same name is created on the window object. In this case, fields for wrap, clicks, and button will be created. Basically, all elements with IDs will be directly accessible by their identifier. This, by the way, is one of the reasons why it's not recommended to use IDs too often, as you end up cluttering your global scope. Anyway, let's get to it. First, we need to define what programmatic generation is. What are we trying to defend against? In the context of clicks, programmatic generation is obviously clicking on a button or some other element not with a mouse but with a script. So the simplest example is if I select this element, the button, and get a reference to the current element using $0, and then call the click method. This is the most standard approach. After I've called it, you can see the handler fired and the counter increased. There you have it, a clear example of programmatic generation. Since I can easily automate this, I can get the button by its ID and call its click method. This is very easy to do with any script. Later we'll look at other ways to programmatically generate a click. This is just the simplest one. Now, let's look at the ways that exist to protect against these kinds of programmatic clicks. We'll examine three main types of protection. In reality, of course, there are more, but the three main ones are as follows: the isTrusted property, the shadow DOM, and event inconsistency. Let's go through them in order, starting with the isTrusted property. First off, let's understand why the isTrusted property exists and how we can check it. To do that, we can simply add a console log here and output the event object that we receive in our handler. Ctrl+S, refresh the page and click. As we can see, a pointer event is fired. And the very first property is isTrusted, which in this case is true. This property is specifically designed to distinguish between events generated by a user, which have isTrusted true, and events generated by JavaScript code. If we try to generate an event with JavaScript code, like we did before with 0.click, the pointer event that comes through will have isTrusted, false, as you can see. Based on this parameter, we can build our defense system by simply including the appropriate check, if E is trusted, and wrapping everything like this. Or we could do it a little differently. Using a guard clause, we can negate it here and instead of wrapping, just return, just like that, as an alternative. And if we do that, let's go back and see. Refresh the page, and when I click with a real mouse, the clicks go through. But if I try to make programmatic clicks like we did before, they don't go through. I'm calling the method, but the clicks aren't registering. I have the button selected, but despite that, the clicks don't work. Now, let's put ourselves in the shoes of an attacker and think about how we can bypass this defense system based on the isTrusted property. Well, not counting the obvious method, which is that our score is a global variable. Of course, I can access it directly here. Score plus equals 1 or something like that. But that doesn't count, obviously. We're talking about protecting the clicks themselves. Besides, I can easily make it private simply by using an immediately invoked function expression, IIFE. Let's do that just in case, so there are no extra questions. Just like this. And now the score variable will no longer be visible in the global scope. It can't be accessed. So, yeah, and since our if.isTrusted check is active, programmatic clicks also don't work. The question is, how do we get around this? And actually, if you think about it, you might come up with a script like the following. Before you is a tampermonkey script, designed to defeat a defense system based on the isTrusted property. So what's the point of it? We want to override the addEventListener method, that very same one used to set the listener. We want to replace it, we'll save a reference to the original, and we'll override it with the following. Instead of the original callback that comes in when addEventListener is called, we want to create an updated callback. Inside this callback, when the event object comes in, we can just manually set isTrusted to true, and then call the original callback, passing it our modified event object, where isTrusted is now true. And then after defining that callback, we set the original event listener with this modified callback. So it's basically this clever layer where when we call add event listener, it's not this callback that gets set, but our updated callback, which is designed to first change isTrusted to true and then call the original callback. That is this one, and pass it the modified object as its event. And if we try to do that, of course, we also need to specify run at document start. And as we discussed in the previous video, in the TamperMonkey settings, you need to select advanced. And as someone pointed out in the comments, under security, content script API, choose user script API dynamic, and be sure to hit save here, because otherwise TamperMonkey might not inject in time. That's something we talked about in the last video. Okay, so let's see what happens with this script activated. We'll enable it, go back and try to generate a programmatic click on the button. And we see that it doesn't work. We get an error. We can't set the isTrusted property because it only has a getter. So our attempt has failed. But those who are a bit more clever know that properties in JavaScript aren't just defined like that, but also through object.defineProperty. And this is a more advanced way of creating a property that allows you to set a getter and a setter. And here for the object, we're trying to use our event object for the property key isTrusted. And as the value, we'll try to set a getter for it. So get, and inside get, we return true. We can try to do it this way. Let's try and see what we get with this approach. Let's see what happens with a programmatic click. I'll probably just do button.click. I have a permanent reference to it. And we see we still get an error, but for a different reason now. It's because I can't redefine property isTrusted. So why is this happening? Because we're dealing with a non-modifiable, non-configurable property. And how can we be sure of that? It's quite simple. Here, instead of trying and failing to change it, we can just log object getDownProperty descriptor to the console. What will we see in the console? Refresh, click, click, and we see configurable, false, and the setter is not defined. Configurable. False means that we cannot reconfigure this property in any way using define property. Basically, the browser developers anticipated this and intentionally locked this property from modification. Of course, the source code for Chromium as well as Firefox is open source. You could recompile it and build a version of the browser where configurable is not set to false. However, that's a very labor-intensive approach and it has its own drawbacks. At this point, you might get the feeling that there's no easy way to change this property. Actually, that's not true. There's a crafty little trick that still allows us to change this cursed property here in TamperMonkey. And we're going to look at that method right now. And the trick is this: if we can't in any way modify the isTrusted property on the e-object that comes in, then why don't we just create our own new empty object and copy all the existing properties from the original e-object into it. So we iterate through the properties of the e-object. Now we've intentionally used a very simplified version here. We'll look at the property name. If it's isTrusted, we copy true into our new event object. Otherwise, we copy everything as is. And then into our original callback, we pass not the original event object, but our updated, crafted on the fly, so to speak, object, which simply sets isTrusted. True this way, and we pass it in. If we do that, Ctrl S, let's see what happens. Refresh, select the element, or just use button.click. And as you can see, hallelujah, we've bypassed the isTrusted check. As you can see, I'm typing the button.click command, and the score is increasing. Meanwhile, if I were doing this without TamperMonkey, nothing would happen. So this effect is being caused specifically by this little trick. So what's happening is our handler is receiving a substituted event object where isTrusted has been set to true, and this updated event is passed to the original callback, that is right here. What arrives here is not the original event object, but a fake one. And from here, you could check it in a huge number of ways. For example, you could just check if e-instance of pointer event, and in that case, we would once again fail this check. Ctrl+S, refresh, and now we once again can't generate events this way. But in this case, that's easily fixed if we just swap out the prototype. That is, for our plain object, we set its prototype to be the same prototype as the original object had. If we do that, we will once again bypass this defense. And so it's effectively an arms race. Look, we can generate clicks again, then I could add another check here and so on. There could be a huge number of such checks, really. I intentionally used a simple method here in TamperMonkey to make it clear how this works, because ideally we shouldn't just be copying by value like this. We should be doing it via a getter, because as you remember, the real isTrusted is set via a getter, whereas ours is set as a value. In case you don't know, properties in JavaScript can be of two types: data properties or accessor properties, depending on how the value is stored, either simply as a value or via a getter setter. In our case, we're just dumbly copying everything by value. We should be copying via descriptors. Furthermore, This should all be done using a proxy and so on. And even if we did all that, use the proxy, use descriptors, and fully maintained prototype integrity, there are still clever checks you can put right here that can detect those proxies. But that's a topic for a separate video. I think you get the general idea. In this case, we've bypassed these two checks with this code and can now generate programmatic clicks. Well, with this method, I think the general vector of attack and defense is more or less clear to you. On that note, I propose we wrap up this installment, and in the next parts, we'll look at the remaining ways to protect clicks. I hope this information was useful for you. Good luck, and see you next time.